In the last couple of chapters, we talked about how to install an SSL certificate so that it's there and up and running. Now we need to talk about how we make a few more configurations to really get HTTPS in the state that we want it. And the first and most important thing is we want to redirect requests that come in over HTTP, that is insecure requests. We want to redirect those to HTTPS. By default, when you type a URL in your browser and you type http:// that's going to send that request to port 80. That's the standard web port that most web browsers use. And we saw that when we were looking at the configuration files in the last chapter, that the configuration was listening on port 80. You may have noticed that when we implemented SSL, we did it on port 443. That's the default for these secure requests. It keeps them separate. So insecure requests come in on port 80, secure requests come in on port 443. So if you type HTTPS, it's going to send that request to port 443. What we need to do now is redirect all requests that come into port 80 to port 443, because we don't want them going to port 80 anymore, right? We're going to be using HTTPS all the time. Now, if you did this using certbot and Let's Encrypt, it can configure this for you automatically. It's one of the steps that it asks you in the process. It says, hey, do you want to do this? Most times you want to say yes. You want to say, yes, please configure that for me, and it'll take care of it. But if you got a purchase certificate, then you'll need to add a configuration to make that happen. If you're using Apache, you just want to make sure that you have a separate virtual host configuration that includes :80, so that's on port 80. And then you want to make sure that you have this line that says redirect permanent. Now I have document root there as well. You actually, I don't think even need that. I think just having redirect permanent will tell it to redirect everything that comes in. That's what the slash means. Everything in every directory that comes in is going to get redirected to https:// and then your domain. That will then redirect all those requests. A request will come in on port 80. Your web server will say, hey, you got the wrong place. Here's the new one. It'll send that back to the browser, and the browser will immediately make a new request on port 443 and get the secure connection. If you're working with Nginx, then you'll want to have a separate server directive, that is server and then those curly braces, a separate one from what you had for 443. This one's going to say listen 80, and we're going to tell it to return 404, which means that everything is going to be returned as not found. But if the host equals yourdomain.com, if that's what they're asking for, then we're going to redirect them. That's return 301. That's a redirect. 301 is the HTTP code for a permanent redirect. So return a permanent redirect to HTTPS and then $host $request_URI. So basically it says whatever you just asked for, I'm going to tell you to ask for it again using HTTPS. Once you do that, either requests that use HTTP or requests that use HTTPS in the URL will both get directed to your secure HTTPS connection. And all requests that come into your website will be using your new certificate. In this movie, we're going to talk about something called HTTP Strict Transport Security, or HSTS for short. A few years ago, browser developers came up with a great idea. If we want everyone to be using the web as securely as possible, then it'd be a great idea if they had the ability to tell web browsers that they should only interact with some websites using HTTPS. If we could tell them, then they would know. The browser could remember that fact, and it could automatically direct all requests for that website to HTTPS. There would be no more insecure connections. Now, in the last movie, we went ahead and told the web server that it should make this redirect for us. But remember how that happens. The browser first makes an insecure request to the web server. The web server responds by saying, oh, no, you want the secure connection. So it sends an insecure request back to the web browser. The web browser then says, oh, now I understand. I'm going to reissue the request on a secure connection, and it issues the request back. But there's first that insecure connection that happens. This prevents that because now the web browser knows to automatically redirect. We never have to make that insecure request. That's important because it protects us against something called downgrade attacks and man-in-the-middle attacks, where hackers could potentially capture that insecure connection and they could steal our cookies or our session ID, or they could even respond to that request by doing a redirection of their own to send us to a fake website. For example, they might redirect your insecure request to a website that looks like your bank website, and you enter your credentials thinking you've now been redirected to the secure version of your website, but you're in fact entering those credentials into a hacker's website. So that's a problem that HSTS can help us solve. The way that you do that is you add a directive to the HTTP header. So the first time that a browser comes to your site, it may or may not be making a secure request to the site. But once it makes that first one and it gets this directive from your web server, well, then it knows from then on, all connections should use HTTPS. The directive name in the header is called strict-transport-security. That's what the browser is looking for. And it wants to know how long it should remember it and any other information you want to provide. So typically it would say max-age equals, and then the number of seconds that the browser should remember this setting. In this case, I've set it to 300, which is 5 minutes. And then I've told it to also include subdomains. So it's not just my main domain, but all subdomains as well. That's up to you. If you wanted to remove that because you didn't want all subdomains, you could take it away. But typically you do want it there. And then once you've done that, you restart the web server. So how do you add this directive to the HTTP header? There's a number of different ways that you can do it. The most common way, if you're using Apache, is to add a directive to your secure virtual host file. That's the one that ends in :443, and just add a directive called header, always set, and then the name, strict-transport-security, and then in quotes, what we want to set. Max age equals 300, semicolon, includes subdomains, semicolon. If you were on Nginx, you would also add it to the server configuration that says 443 on it. That's the one that's for SSL. And we would say add_header as the directive. Again, strict-transport-security, and then in double quotes, max age equals 300, semicolon, include subdomains, semicolon. And then notice I have a second semicolon. The first one is a semicolon inside the quotes. That's what we're setting in the header. The second one is a semicolon that's actually for Nginx's configuration. Once you've done that and restarted the web server, then browsers will remember for the time that you've specified to only use HTTPS for their connections. Now, it's a good idea to start with a small number like 5 minutes and then increase the maximum age over time. So it's always expressed in seconds. So 300 seconds is 5 minutes. Once you get that working and you feel confident about it, then up it to a bigger number. So if we had a bigger number like 1 week or a larger number for 1 month, once we know all those are working, then we can go ahead. The sort of gold standard, the one that we're really looking for, is 2 years. That's ultimately where you want to end up. So start with 5 minutes just to make sure that if you screw something up, you don't have to wait too long for things to reset themselves so you can try again. But once you have it working, try and get up to 2 years. The reason why is because once we get to 2 years, we can take advantage of something called HSTS preloading. We're going to talk about how to do that in the next movie. In this movie, we're going to continue our discussion of HSTS by talking about a great feature called preloading. Let's review what we've talked about with HSTS so far, and let's do it by thinking about the steps that happen when a user tries to interact with a website starting with an insecure connection. So the user goes to the browser and they enter http:// and the domain name. That's not going to be a secure connection because they used HTTP. The request is going to be sent by the browser using HTTP on port 80. Then the web server is going to be told that it should redirect all requests on port 80 to use HTTPS. We did that in the first movie of this chapter. After that, the web browser is going to say, oh, okay, I misunderstood. Let me resubmit the request, this time using HTTPS on port 443. And then we've configured our web server already to use our SSL certificate and to respond to that correctly. In the last movie, we also told the web server to send back a header with an HSTS directive as well, essentially telling the browser, hey, don't make that mistake again. From now on, for the period of time that I've specified, I want you to always use HTTPS. So we've now managed to secure things going forward. However, what about that very first connection? That very first connection is still going to be an insecure connection. Now, if our user was smart enough to use HTTPS the first time, then they'll get that HSTS directive and they'll never have an insecure connection. But if they start out with an insecure one, there's still that chance that that very first time they would do something insecurely. That's what HSTS preloading helps us solve. The browser keeps a preloaded global list of HTTPS only websites. It's a list of every website that is supposed to use only SSL. It's a long list and it's getting longer. It's available on Chrome and on most major browsers. When I say major browsers, that's Firefox, Safari, Internet Explorer 11, Internet Explorer Edge, Opera. It's a long list. Now I highlight Chrome there separate from the major browsers because Chrome is the one who spearheaded this project, and they're the ones who maintain this global list that most of the other browsers use. Now the header is still useful to have for other browsers, they just won't get the advantage of preloading. In order for us to use preloading, we have to do a couple of things. We have to first do all of the security measures that we've already done to do redirecting and everything to include the HTTPS directive. The HTTPS directive must also have a large enough maximum age. It must be at least 1 year, but 2 years is preferred, and you should include subdomains, and then you have to add at the end of it, after the last semicolon, preload. That tells it that you would like to preload this. And then you must go to a website for htstspreload.org and submit your site and tell Chrome, hey Chrome, I would like to be added to this list. I would like you to check and see if I'm eligible, and if so, add me to the list. If you're accepted to that list, then the next time that a user receives a browser update and they update their browser software, their browser will receive the updated list and your site will be on it. Let's go to the HTTPS preload website. So here's what the HTTPS preload website looks like right now. That may change over time, but you'll see that you can just enter a domain up here and then click the button and it'll check to see your preload status and eligibility to be included. It goes on to provide information about this and how this works, what browsers are included. There's a compatibility matrix that you can check out. It has the submission requirements. Those are the things that we've been working on throughout this tutorial. Have a valid certificate, redirect everything from HTTP to HTTPS, so that if we're listening on port 80, everything goes to port 443. Serve all your subdomains to HTTPS. Serve an HTTPS header on the base domain. The maximum age must be at least 1 year. 2 years is what they recommend. The include subdomains directive must be specified. Preload must be specified. And if you're serving an additional redirect, that redirect must also have the HTTPS header. That's a minor detail that we won't need to worry about. And then they give you an example of what that looks like. So I encourage you to follow all these steps. It's a way to build up your security over time. First, start by adding the SSL certificate, then redirect all of your insecure requests to make sure that they use that certificate on a secure connection, then set up HTTPS, slowly increasing the maximum age till you get that sorted out. And then once you have all of that working, set up preloading so that all browsers will know that your website should be HTTP